Okay, here's your explanation for those ones you needed. Uh, I do a better job for the last couple ones, but the first one I should have given you a picture right here. So this is the basic setup. So you're given that the side length, the JL is 9, and then you're given one of the bottom measurements. One of them is 6, and the other one is you need the entire bottom. So the entire bottom, since you don't know what MK is, MK would be X. So the entire bottom would be 6, that's JM, plus the unknown, in this case, X. So it'd be 6 times the entire bottom, which would be 6 plus X. So how do you solve this one? You square both sides. Remember, the inverse of squaring is square rooting, or inverse of square rooting is squaring. So those would cancel. So you're left with that. Do a little bit of a distributive property, and then just solve this equation right here. So subtract 36, divide by 6. It's going to give you a decimal. If you leave it as a fraction, because you need to use this information for the next one, probably best to write this one as a decimal. All right, so number 30, it's the same thing, just it's solving the right side. And on the right side, you have that one piece that's 7. It's the same drill. So the bottom, MK is 6, and the other piece, LK, or sorry, JM is missing. So the entire bottom will be 6 plus the missing side. The missing side we'll call X. So the entire bottom is 6 plus X. And then we need to times it by MK, which is 6. And then just like 28, same thing. Square both sides, do a little bit of distributive property, and then solve that equation right there, and you're done. Now, this one's really ugly. You get 13.6. So if rounding, that would be about 2.2. All right, so the last ones are absolutely the most challenging ones. So these are only challenging because you wind up with quadratics. You got to solve a quadratic equation. And there are lots of steps here. So the question is, where do you start? Well, notice what we have here. There's only 2 values there. The entire bottom. Well, let me flip it around so it looks like what we can from our picture from our book of truth. So we're given the entire bottom, we're given the right side. So I mean, that's where you need to start, solving for the right side. Now I flipped it upside down. That's a 9, not a 6. So let's see, 9 would be equal to the square root of the whole bottom, which was 15 times X. And then just as we did before, we're going to square both sides. And then this one, it will give us a fraction right here. And so that's the value of X. So let's see, if that is the value of X, I'm going to write as a decimal, make my life easier, 5.4. If that is X, and the entire bottom is 15, so I can calculate Y just by doing 15 minus 15, 5.4 gives me 9.6. All right, cool. So I got X, 9.6. What would be the next one I would solve for? If I got X and I have Y, Y 9.6, well, then I can solve for Z, right? So for Z would be 9.6 times 5.4. Now that looks really ugly. Yeah, you're going to need a calculator for this one. So multiply those two and then take the square roots. You're going to need a calculator for this, and you get 7.2. So that one's not too bad. I just said this one would be a quadratic. This one's not the quadratic. It's the last 2 that are quadratic. This one was pretty straightforward once you knew where to start. So the key of knowing where to start here is knowing that, well, the only 2 bits of information was that 9 and 15. All right, on to the quadratic ones. So once again, I'll flip it so we can look at it. So the only number we're given there is 12. Clearly, we're going to start in the middle. So 12 would be equal to the square root of the left times the right, or the bottom left times the bottom right. So that would be X times X plus 7. Same drill. We're going to square both sides. So we square both sides, and then we got to do the distributive property. X times X is X squared. We got a quadratic. So remember to factor a quadratic. That's our ultimate goal here. I need to move everything to one side so it's set equal to 0. So I did a little bit of trickery there. I just rewrote it so that the X squared is on the left. You don't have to. You can leave the X squared on the right. But you do need to have the equation set equal to 0. Now we're going to factor it. 2 numbers that multiply to negative 44 to add to 7. That was a little bit challenging because it's large numbers, but ends up being a positive 16 and a negative 9. 16 times negative 9 is negative 144, and 16 minus 9 is positive 7. So remember the 0 product property. You set both of those equal to 0, so you get final answer of negative 16 and positive 9, but we have a problem. Look back at the shape. We're saying X could be negative 16. No way. X can't be negative 16. Algebraically, it can be negative 16, but geometrically, it can only be 9. So it's got an extraneous solution. So therefore, X is equal to 9. And once I know that X is 9, I got the entire bottom. So looking at it in the flip version right there, the left side is x plus 7, so that's 16, and the right side is 9. All right, so if I know that, now I can solve for y and z. It doesn't matter the order I'm doing. I forget which one I solve first. Y, yeah, okay, y. So y would be equal to the entire bottom piece if x is 9. So that would be, I've got this wrong. So that should be 9 plus. Oh, no, I'm sorry. The entire bottom. I just confused myself there. So the left side, 7 plus 9 is 16. And 16 plus 9, the entire bottom, would be 25. Oh, I confused myself there. So y would be equal to 25 times 9. There we go. Square root of 25 is 5. Square root of 3 is 9. Or square root of 9 is 3. So that would be 5 times 3, which is 15. And then we can do z the same way. So z would be equal to, let's see if I can do this right this time, the entire bottom. So the left side would be 7 plus 9, because remember x was 9. So that's 16 plus 9 is 25. So square root of 25 times 16. So that would be 5 times 4, which is 20. There we go. And now I'm not going to go individually steps through the entire the last one. The last one is done exactly the same way. Here are all the steps. This one's a little bit uglier in the procedure, because look at what you got to square a binomial. So if you square 2 plus x, look on the left side there, on the very right side of the screen there, look on the left side of the equation. I've got a 2 plus x that I got to square. So that would be 2 plus x times 2 plus x. So that would be x squared plus 4x plus 4. And then on the right side, once I distribute that x to the inside, x plus x is 2x. So x times 2x plus 1 would be 2x squared plus x. Now I'm going to move everything to one side before I factor. So subtract x squared, subtract 4x, subtract 4, and we get x squared minus 3x minus 4. Two numbers multiplied to -4, they add to -3. That would be -4, +1. Zero product property, you know the drill. So that would be -1 and +4. Now look back at the shape. We can't claim that x is -1 because it can't be. It's geometry. Although algebraically it works out, just not geometrically. So therefore x has to be 4. And then we do the same process as before. Solving for the y value. So y would be equal to left bottom piece times right bottom piece. If x is the value 4, then the left bottom piece is 1 plus 4, 5. And the right bottom piece is 4. 5 times 4. Square root of 4 is 2. So y is equal to 2 root 5. And then z, you can see the work there. It's done the same way. All right. If that was not helpful, ask again, and I can state it in a different way.